It's happening here and now. New urban landscapes are emerging before our eyes. But what will our cities look like in 20 or 50 years? Will they be more livable? Or is urban improvement merely a utopia? The answer lies in intelligent planning, innovative building technologies, and urban greening. Today's so-called smart cities are the proving grounds for the cities of tomorrow. Singapore is a leading business location and on its way to becoming a so-called smart nation. The small city-state, barely twice the size of Vienna, can only grow in one direction, upwards. 96% of Singapore's 5.6 million inhabitants live in high-rise buildings. Sustainable construction is encouraged by the government, since water, energy, and building materials are scarce. Singapore's University of Technology and Design offers classes in sustainable architecture. One of the professors comes from Austria.
And then the courtyards and all these open void spaces in between. But you can also see that the concrete elements are shaped in different ways. And these features also provide shade to these parts of the facade. Singapore, since we're almost exactly on the equator, we have most solar impact on the east and west facades. And that's why here on the north and south facades we have very long stretches of facades because there's not much solar impact. But then when you look at the ends here, 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 all the east and west facades are very small, so they don't have as much solar impact in the ends.
The facade's overhanging metal and concrete elements shield against the tropical heat. The design allows for sufficient daylight inside while also providing shade and protection against rain. In recent years, architects have also increasingly focused on greening.
Singapore
is often called Asia's greenest city. The tropical climate plays an important role as it helps the vegetation to grow quickly. In turn, this green component has a positive impact on the climate in the city. For example, the shade provided by the many trees helps keep the sidewalk and street pavement from getting too hot. And the green facades have a similar effect, providing shade to keep building temperatures much cooler than they would be otherwise.
Die Temperatur, die sie sonst einfach aufheizen würde, mithilft, relativ kühl zu halten.
Plants overgrow skyscrapers, forming lush vertical gardens that benefit the microclimate and quality of life. This urban jungle is a low-tech solution for climate issues. The city's green buildings make Singapore an international role model. The United World College is a certified green building. The huge campus was developed with sustainability as the guiding principle. It is only 8 a.m., and the outside temperature is already 30 degrees Celsius in tropical Singapore. With staggering amounts of energy used each day to keep this city's air conditioning units running, the school leadership was intent on finding a less wasteful alternative for keeping the classrooms cool. In 2012, one of the world's largest solar cooling systems was installed. It was developed and tested in Austria. On the college's roof, high-performance solar collectors produce boiling hot water, even with diffuse sunlight, which often prevails in the tropics. The solar plant can supply the entire warm water needs of the school, its boarding home, and canteen. In addition, the solar-heated water is used to pre-cool the classrooms. As a result, the school building uses up to 60% less power for electric cooling than the average building in Singapore. The plant's dimensions are impressive.
The solar thermal collector field has a size of approximately 3,900 square meters. It is the biggest system, the solar thermal system in Singapore. The heat produced by the solar collector field is transmitted to the solar storage tank via a network of pipes, which is approximately 2,400 meters in length.
30 minutes before classes start, the chiller is activated to convert the hot water from the solar collectors into cool water via evaporation. It is pumped into a network of pipes to pre-cool the classrooms. Thanks to its state-of-the-art facilities, the school has achieved Singapore's highest green building certification.
You're going to have to reload the whole page because of that sensor.
In the northern hemisphere, buildings must be heated. In the tropics, they must be cooled. These researchers have also developed an experimental concept for cooling buildings and are able to test it at the school. An office building was built according to their design.
In Singapore, if you want to look at energy efficiency in buildings, you're going to immediately point to air conditioning. It consumes about 60% of the building stock's electricity consumption in the country. We're looking at adapting very thin, compact air conditioning systems that are more energy efficient. A developer who builds a high-rise building may not be as incentivized with energy savings as they would about saving space, either making things larger, more atrium-like, or perhaps, as 3 for 2 is, putting more floors into the standard space of 3 for 2. So that's, in a nutshell, the concept. What we've done here is build a pilot to demonstrate this technology.
The building design concept was developed at the Future Cities Laboratory, a testing ground for futuristic research established in 2010 in Singapore as a branch of the ETH Zurich. Over 100 architects, urban and traffic planners, engineers, IT specialists, and historians from 29 nations are here to plan the cities of the future. A young engineer from Austria is assisting the project group for building cooling.
The big difference between conventional systems and our 3 for 2 concept is that we use water-based cooling instead of the usual air-based design. This has several key advantages. For one, it's more space efficient because we use relatively thin water pipes instead of large air ducting. Plus, it is more energy efficient due to water having a much higher heat capacity than air.
An infrared camera shows where the thin pipes carrying cool water run along the ceilings. These replace the large air ducts used in conventional air conditioning systems. As a result, 3 floors can now fit in the same space as 2. With more and more people living in cities and climate change as well as urban heat effects causing temperatures to rise, an increasing number of high-rise buildings will need energy-efficient cooling systems. Sensors installed in the school office provide the researchers with continuous real-time data. The data can also be accessed online by scientists anywhere in the world, allowing them to take virtual tours and to learn from the pilot building in Singapore.
Okay, inside the space it works nice.
Yeah, it gives us some information here.
You move, yeah, it doesn't work as much.
No, I'm moving it, yeah.
Digitalization, rapid data transfer, smart software, and high-tech electronics are revolutionizing the field of construction research. New imaging and simulation technologies are being tested in Gleisdorf, Austria.
We need to get the entire side of the facade to clearly distinguish the windows and thermal bridges. Right, we need to watch the trees.
This one-of-a-kind research project started during winter. The early morning cold presents the ideal conditions for the high-tech cameras, which are mounted on a hot air balloon. Their job is to capture color and thermal images of entire city districts. The researchers are systematically scanning for hotspots or buildings in need of improvements. they are much easier to spot from a bird's eye view.
Hotspots are what we call areas in a city where energy efficiency is low. This can be due to heat losses on facades or roofs using the wrong energy sources for heating, and so on. There are a number of criteria for defining a hotspot, so we need to analyze the information in more detail.
Technically advanced drones equipped with infrared cameras are used in the second part of the research project. Thermal imaging from the hot air balloon has identified the city's problem zones, but these must now be surveyed in more detail using the drones.
These are the color and thermal images.
The aerial images are fed into image processing software that was developed in Austria specifically for this project. It generates a three-dimensional model on which the thermal images of each house or entire city districts are superimposed.
Die 3D-Aufnahme hat einen wesentlichen Vorteil.
3D imaging offers a major advantage. Not only can I view an individual facade, but also the building's corners, ledges, eaves, and roof. I can identify all of the hotspots and thermal bridges from a single image, and I can also rotate the view to more easily determine the needed improvements.
Und so viel einfacher die Sanierungsmaßnahmen erkennen und festlegen.
The 3D analysis identifies energy losses. The simulation software recommends the necessary improvements. This provides valuable information to city leaders and homeowners alike. The need for improvements is huge. Nearly half of all buildings in Central Europe date to the post-war decades. In Kapfenberg, too, the focus was on building quickly and cheaply. Today, a pilot project is underway to test a completely new renovation method that does not even require residents to vacate the building. The method is being tested on an aging building dating from the 1960s. The former energy guzzler will be turned into a modern plus energy house that produces more energy than it consumes. Ready-made, high-tech facade elements containing the building's entire technical systems are being installed on the outside. It took researchers over 2 years to develop the prototype.
It's great when others acknowledge that you have created something innovative.
The prototype will be tested on the building for 6 months with continuous monitoring and optimization. The curtain wall will envelop the old building's exterior, heating and insulating it, and even producing electricity and hot water from renewable resources.
I'm convinced that this will be the future of construction. From planning to the building's equipment, all we do will be based on ecological sustainability. If not, the future will be bleak. So it would be irresponsible of our profession to act otherwise.
The prototype has proven successful, and the multifunctional facade can now be permanently installed. Water pipes, power lines, and thermal insulation are all integrated in the prefabricated elements. It takes only a few weeks to complete the renovation. The newly adapted building stands among its outdated neighbors. It is able to generate nearly all the energy it needs using the components integrated in the curtain walls and roof. The new facade system benefits everyone: inhabitants, owners, and environment. After 2 years of testing on the building in Kapfenberg, the new system will go into series production. Austrian know-how also provides a win-win effect for Singapore's Changi Airport. A hub serving over 60 million annual passengers, it is ranked as the world's best airport for several years running. Lighting specialists from Tyrol have developed a unique daylight system for Changi Airport to ensure a sense of well-being. The key innovation is located on the roof, often unnoticed by travelers. Movable panels are positioned above each of the 900 skylights of the departure hall. The panels open and shut like butterfly wings, depending on the time of day, angle of the sun, and weather situation, to let in the right amount of natural daylight while keeping out the heat. Aluminum reflectors help direct the daylight, and thousands of perforated metal panels hanging from the ceiling disperse the light to maintain perfect daylight conditions inside. Artificial lighting is only used at night. The light management system not only ensures traveler comfort, but also saves power for lighting and cooling, so additional costs have been recovered in only 5 years. The high-precision reflectors efficiently and equally disperse light without blinding. The innovative system and its Tyrolean developers are now known around the world. Cities occupy only 2% of the Earth's surface, but consume 75% of all resources. Clearly, we must change to a more sustainable lifestyle that consumes less energy and natural resources. Animations show what a smart city might look like, in this case on a futuristic walk through Graz. The Styrian state capital is receiving a new landmark, the Science Tower, which is being erected next to an event hall on the former site of a steel plant. The tower will stand like a sculpture in the heart of a new smart city that will be completed piece by 2024. As its name implies, the new Science Tower will also function as a technology laboratory. New energy technologies are being tested on the building, and soon it will house research companies and startups focusing on green technologies. Built in the present, the tower symbolizes a more livable urban future, while providing a view onto the city emerging around it on the 400-hectare site.
Wir haben in Graz Universitäten mit 60.000 Studenten.
In Graz, there are 60,000 students attending universities, and a number of leading international companies make their home here. Overall, Styria is currently the region with the highest research and development rate in Europe. And I think that's because we've been able to build a fertile environment for it. So I don't think it's a coincidence that this Smart Cities project is happening here in Graz.
The Science Tower is an impressive new landmark and the centerpiece of Smart City Graz, one of several hundred urban development projects in Austria. Funded by the Austrian Climate and Energy Fund, the project is unique in Europe. A metal collar installed atop the 60-meter-high building provides the supporting structure for its innovative energy glass.
Wir haben uns vor 10 Jahren das erste Mal damit beschäftigt, welche Technologien
We first looked into what technologies might fit in the tower 10 years ago, starting with the facade. Well, we learned that we could use it to harvest energy and perform energy management functions. So we developed a totally new glass technology on the basis of work done by Professor Grätzel.
Basierend auf den Grundlagen von Professor Grätzel.
It's modeled after photosynthesis, meaning it can harvest light energy like plants do, but the energy is converted into electricity, whereas plants use it for metabolic functions and to grow. The electricity is used to power the building systems. Any excess can be stored or fed into the power grid. Once many buildings can do this, it will be like David versus Goliath, with lots of small power plants replacing the giant ones.
Die gemeinsam große Kraftwerke, um nicht zu sagen Atomkraftwerke, ersetzen können.
2 years after groundbreaking, the tower began functioning as a small power plant. At ground level, 12 200-meter-deep holes were drilled to use geothermal energy. Around the tower's exterior, 2 thin glass layers, each only 2 millimeters thick, hardened in a salt bath at 450 degrees and laminated. Next, ultralight photovoltaic modules which follow the sun, circumnavigating the building every 24 hours. They provide sun protection and produce electricity. And at the very top, the peak innovation, revolutionary energy glass with dye-sensitized cells, invented by the Swiss chemist Michael Grätzel. The cells absorb sunlight via dye pigments instead of silicon to produce electricity.
When we began designing the building, energy glass was purely in a research stage. The first Grätzel cell back then measured only 1 square centimeter. Great potential, but much too small for a facade. So we didn't know if it would be ready in time, but we were all convinced that it was the right technology.
The cells generate electricity even in diffuse light, with excess power fed to a microgrid. In the near future, electric vehicles will be able to charge their batteries at the foot of the tower. In the meantime, the building's first occupants have moved in. They have big plans for the highly livable urban future that is coming into being on the idle industrial site, no doubt encouraged by the latest innovations in building technology.
We considered a lot of different potential solutions. You could describe the process as moving 2 steps forward and 1 step back. And it's not finished yet, because in the years to come, the science tower will continue to be used for testing and implementing new technologies.